Hi everyone, this is my Squishy Circuits presentation, so let's get started. So for my lesson, I wasn't sure what to do. So some of the best STEM lessons that I have done have come from books. So one of the books that I like reading with my students is Orion in the Dark. So just a quick overview. So Orion's least favorite thing was to go to sleep. He was afraid of the dark until one night the dark comes to visit him and he does a bunch of activities and he finds out that it's not so scary. So my lesson is that after reading the book, the teacher will discuss squishy circuits and explain how conductive and insulating dough can create energy to produce sounds and light. So students will work in groups to create a nightlight buddy to help ease fears in the dark. It's pretty relatable for kids this age. A lot of kids are afraid of the dark. I being one when I was this age in kindergarten or first grade. So just the goal of this lesson is for students to design a product that takes the flow of electricity through a circuit. And then while they're learning about that, they need to log their experiences in an engineering design journal. So what can I do with circuits that will help a room not be dark? Or some questions, would a flashlight scare away the dark? How would I make a flashlight that would not roll off my bed? So I did this from a little kid's perspective. So a nightlight plugs in the wall, but I am too little to use an outlet. Could I construct something that sits on a table that would not need an outlet? So some possible solutions would be a nightlight or a flashlight. So I posed the question of how will you make a nightlight buddy to help ease Orion's fears of the dark? So one of the biggest things that at a young age is they're not sure of circuits. So before having them jam all kinds of different circuits into Play-Doh, there is a circuit construction simulator that shows kids from the University of Colorado that shows kids how to use circuits, and then they can take a screenshot of their work. So I did the PHET circuit construction to kind of show that, and I also looked at a TED talk just about squishy circuits in general for my research. So I plan on making a turtle or a dragonfly with LED lights and sound. So I created the turtle at the bottom, and I was able to put lights to make it light up so that in the dark you didn't have to plug anything in. So some ways to improve it, I did improve it by using the sound feature. However, some things that really could have been improved, sounds and lights to work together, add a motor or a propeller, perhaps a fan, because as we know, sometimes when we're sleeping, not only are we afraid of the dark, but we also get hot. To use some household items to see if they're conductors of electricity. The animal itself needs to be larger. Use of a switch might be another possibility. To try a possibility of the dragonfly design or to start the process over. And just know that attempts that failed definitely help the end solution be better. So here you can hear the sound that came out of the turtle. So the last piece of this was the lesson plan specifications. So does the lesson present a real problem? I said yes, because most children are afraid of the dark. Will students relate to the problem? Yes. Again, a lot of kids at this age, kindergarten to first grader, are still afraid of the dark. Does it imply important science and math grade knowledge? Yes. They're learning about circuits. They're measuring their animal to make sure it fits in the criteria and constraints, which is in the lesson plan. And they definitely go through the engineering design process of solving the problems because they're recording what they're doing in their design journals. It's hands-on. Children are manipulating Play-Doh. The teacher is hands-on as well. The lesson does lead itself to a prototype because they need to make a buddy that helps ease fears in the dark. The technology is the circuits. The children are required to work in teams. They're testing their stuff with the simulator and trying to experiment and see if those configurations would work. And if it didn't work in their turtle, they were going back. So I gave myself a somewhat. And at the end of the lesson, the children are communicating their design with their peers. That's it, everyone.